Hello, everyone.
Hello.
How are you all doing?
Pretty good.
So I guess we can start. Today we have empirical rule. Empirical rule. We're going to do empirical rule today. Then Friday we'll do Chebyshev rule. And then that will conclude this section of our class. Next week we'll start from probability. So before we start, do anybody have any question before we begin?
No.
No.
Okay, let's start then. Empirical rule is a rule that we use for a distribution that is normal. I think I explained a little bit what I mean by normality at the beginning of this class when I gave you the chart that looks like this, normal. And I'll give you an example what I mean by when we say things are normal. For example, the what we call the normal systolic blood pressure. Systolic blood pressure, we say that it is normal when it is something I think about 110 to 140. Okay, millimeter of mercury, 110 to 140. I'm talking about only the systolic. You know, the blood pressure, usually there are two numbers. One is systolic, one is diastolic. How about this? The average birth weight of a baby, of a young baby, well, babies are young anyway. Babies are young anyway, so I won't say young baby. Now, the normal birth weight is usually, I think about 6 pounds to 9 pounds. Okay, normal birth weights. Okay. So anything below this amount, this value, we say that if it's below 6 pounds, we say that the baby is underweight. And above that, if above 9 pounds, we say that the baby is overweight. So, but we have what's called normal. So for that normal distribution, we say that normal, any distribution that is normal or maybe we say bell-shaped or symmetric, that is where we use the empirical rule. So according to this empirical rule, it says about 68% of all values falls within one standard deviation of the mean. And about 95% of all values fall within 2 standard deviations of the mean. And 99.7% of all values fall within 3 standard deviations of the mean. Now, let me show you what I mean by that. See, the first one says about 68% of all values usually fall within 1 standard deviation. So you can see right here, it's usually 2 sides, left side and right side, with the mean at the center. Then the deviation from the mean, on the left side, we use mean minus 1 times standard deviation. On the right side, we use mean plus 1 standard deviation. If you add these two together, 34 and 34, which I can show you with decimals, you can add a 34 plus 34 gives you 8%. And that is what empirical is saying. Now you can see that it is the same thing on both. See, here is mean minus 1 standard deviation. Here is mean and 1 standard deviation. The only difference is that on the left side, we use a minus sign. On the right side, we use plus sign. Now, for the 2 standard deviation of the mean, we have 95% of it. Now, so how come we have 13% here and 13%, 13.5? Because we already have 68% already there. So to get the number that will be here, we're gonna do 95 minus 68% divided by 2. And I'm gonna show you right away. 95, okay. We got 95. So 95, excuse me, I think I put it the wrong way. 95 minus 68% divided by 2. Sorry, Yeah, we're good. That'll give us 13.5%. And that you can see why we have 13.5% here and 13.5% here. And that's what I mean from this point here all the way to this point. Give us, if you add them all together, you get 95. So you can see this is mean minus 2 times standard deviation for the left side, and the right side is mean plus 2 times standard deviation. So you can see that it is the same mean and 2 times standard deviation, except that on the left side, it is minus, but on the right side, it is plus. Now, the same thing applies to this when it says that 99.7% fall within 3 standard deviation. Okay, that means we already have 95 here. So to get this part, we use 99.7 minus the 95 that we already have and divide it by 2. Why do we keep dividing by 2? Because it is 2 sides, left side and right side. So 99.7, 99.7, okay, well, right here. 99.7 minus 95 divided by 2, give me 2.35%, which is what we have there, okay, on both sides. Now, all this, because this is for symmetric or normal distribution, what we expect to be normal, to what we expect, the usual, what we, I don't know the right adjective to use here, what we expect to be. Of course, there are some, exceptions. Now, these values are set in stones. So you're not, I'm not requiring you to calculate this because they're already there. But we are going to be using this to answer some questions. So instead of starting from the beginning to calculate these numbers, you just use what we have already, and I will show you how that works. Now, remember the mean is at the center. So now, when I said normal earlier a few minutes ago, I used the systolic blood pressure and of course the birth weight of a baby. Now, usually we can even use height. An adult, there's a certain height we expect an adult to be. Below that height is not normal. Above it becomes giant. Below that become dwarf. So, but majority cap in that normal range. So we call it usual range. So look at this. I wrote data entries that lies more than 2 standard deviation of the mean are considered unusual, which means that data values, I hope this will allow me to turn it around. Let me see. Yep, she should. Let me try this one. Data values that are between here and here. Oh, excuse me. I think it will allow me. If it doesn't allow me, I'll use something different. Okay, I think this will allow me. Good. Okay. Okay, let me see. I think he's doing it. This thing can be funny sometimes. Okay, one more try, then I will. I think I got it now. Okay. You know what? I'm going to use something different. This is not working for me. All right. Let me use just a regular line. From here to here. Okay. Good. I consider the usual. The usual or normal. Usual values. Usual. Okay. Okay, got it. Now, but anything beyond that on the right side, from here to this side is unusual. So let me put it so you can see what I mean by that. I got this from here all the way to this place is considered unusual. 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 On the left side, on the right side, we also have unusual on the right side. Right here, anything above 2 is also 2 standard deviation is also considered to be unusual. Unusual. So this is normal from here. Now, questions before we continue on this? Any question for me?
No.
So remember that the empirical rule is used for only for distribution that is normal or symmetric or bell-shaped, and that this part from here for mean minus 2 standard deviation and mean plus 2 standard deviation are considered the usual, and anything above that, like mean minus 3 standard deviation or mean plus 3 standard deviation, is unusual. So that we can be able to answer some few questions on that. So let me look at this question. The first question we'll be answering is this one here. Okay. It says, past results from the National Health Survey suggest that the pulse rate, that is the heartbeat per minute for women, have a mean of 76 beats per minute and a standard deviation of 12.5. Assume that the distribution is symmetric. So how do you know that to use empirical rule? The question must mention assume that it's symmetric or assume that it's bell-shaped. So find the minimum and maximum usual rates. And then next one, part B says, then determine whether the pulse rate of 110 will be considered unusual. So the first question says, find the minimum and maximum usual pulse rate of women. So let's begin. So we have a solution. Okay. Okay. It says that pulse rate, the mean is 76. So I'm gonna put a mean of 76 here. Let me move this back a little bit. Mean is 76 bits. And the standard deviation is what is it? It's gonna be somewhere. Okay, more symbols. Oh, I see it right here. Standard deviation is 12.5. Then part A says to find the minimum and maximum usual pulse rate for women. Now, I've already explained to you that for usual is mean minus 2 standard deviation and mean plus 2 standard deviation. And that I have it here. That entry that lies within more than 2 standard deviation of the mean are considered unusual. See? So that means these are the usual rates. Now, so mean minus 2 standard deviation on the left side, mean plus 2 standard deviation on the right side. So I have it here. So minimum will be mean minus 2 times standard deviations, which is mean is 76 minus 2 times the standard deviation of 12.5. And that will give you the answer. So let me write it down so we can get it from the, I got mean 76 minus 2 times 12.5. Okay. I'll take you to decimals. So that we have 76 minus 2 times 12.5. Okay, it was 51 on the left side. Okay, 51 bits per minute. Then minimum, the maximum now becomes the same thing mean, but not this time we're gonna use plus 2 times standard deviation, okay, which is 76 plus 2 times 12.5 equal. That give us go to decimals, just add plus to what we have already. Change this to plus, and that will give us 101 bit per minute. 101 bits per minute. 101 bits per minute. See? Now this is the minimum, this is the maximum. See? We say find the minimum and maximum usual rates. So the minimum and maximum usual rates. So the minimum and maximum usual rate would be 51 bits per minute to 101 bit per minute. Questions?
No.
Okay. Now B part says, then determine whether a pulse rate of 110 will be considered unusual. Now, a pulse rate of 110 bits bits per minute. When you look at it, you see that it doesn't fall within this range. It is usually like the answer we have at the part A show that the normal range is 51 to 101 bits per minute. And this 110 doesn't fall within this range. It falls outside. It is bigger than 110. So that a pulse rate is unusual. That means something is wrong with that woman that the lady that have this pulse rate. Have to be checked again to see why. Because it falls outside the normal range. So see, that's one of the ways we use empirical rule. So we solve this part, question 1. So just application of this principle. Don't forget, the question must say that the data set or distribution is symmetric or barrel shaped or normal. Now we're gonna try and see another way we use this empirical rule. Here it says here that let's look at this question. It says here that making it in a survey conducted by the National Health Statistics, the sample mean height of women in USA ages 20 to 29 years was 64.2 inches with a standard deviation of 2.9 inches. Estimate the percent of women whose heights are between 58.4 and 64.2. So now we are asked to estimate the percent of women whose height are between this value. Now, remember I told you that the percent are already calculated here. All you have to do is to figure out where to start and where to stop to add. Okay. So, but first of all, let us write down the values we have. Solution. So he said that the National Center said that the sample mean height of women in USA. So mean height. Let me put this way. Symbol mean is, excuse me, a mistake. The mean is 64.2 inches. That's what they have here. 64.2 inches. 64.2 inches. And standard deviation is, we have it here as 2.9 inches. 2.9 inches. Okay. Now they ask you to estimate the percent of women whose height are between 58.4 inches and 64.2 inches. So what you're going to do here is to copy this, because like I told you, it is already done. You just have to use it, and then paste it here. So we'll be able to figure out that percentage. Now, to figure out the percentage, we are told that the mean is 64.2 inches. So this is the mean right there. So you're going to write here 64.2 inches for mean. 64.2 inches. That's for this mean. So we have to get the answers for this side and the answers for this side. This side said mean minus 1 standard deviation. So that means mean, put it in. They have mean minus 1 times standard deviation, okay, equals mean is 64.2 minus 1 times our standard deviation was given as 2.9 inches. Okay, so we have to figure out all the answers for this one, and this one. Then figure the answer for this one and this one and this one. Then we can be able to estimate that percentage. So we have it at equals, I'm going to write it down. 64.2 minus 1 times 2.9. So when I put it in decimal, 64.2. Okay. Clear. 64.2 minus 1 times 2.9. That was 61.3 inches. So 61.3 inches. So you got 61.3. So that means the answer for this part here is 61.3. Okay. Now you do the same thing for the 6 plus base, okay? So I mean mean plus 1 times standard deviation. So I'm gonna get that one. Mean plus 1 times the standard deviation, which is 64.2 plus 1 times 2.9. Now, that will give us the right side. That's this one here. So we go to decimals and then put the answer, change it to plus, and we get the answer right away. So change this to plus. Was 67.1. 67.1. Okay. 67.1. So for this one, it is 67.1. 7.1. So we'll repeat the process for the 2 standard deviation, which means that on the left side, we have mean minus 2 times standard deviation. So we have mean minus 2 times standard deviation, giving us 64.2 minus 2 times standard deviation of 2.9. Okay. This gives us I'm going to write it down and get it from here. Okay. So on the decimals, I will have 64.2 minus, 2 times standard deviation of 2.9. Okay, 58.4. 58.4, we put it right there, 58.4. 58.4. So that means for this side, for the left side here, we got 58.4. Okay. Okay, good. Now, we'll repeat the same process for this side. Okay. We have mean, which is, in this case, we put plus mean plus 2 times standard deviation. So mean plus 2 times standard deviation, which will give us 64.2 plus 2 times 2.9. That'll give us just go to decimals and add plus to this. So I'm gonna do it right away. The decimals, add plus to this. Make it a plus. It was 70. 70. So we come here and put 70. 70. Even. Now, the last part, so we put our 70 right here. 70, of course, 0.0. So say here. Now, last part is this part. Mean minus 3 standard deviation. Okay. So you have mean minus 3 times standard deviation. Minus 3 times standard deviation. Okay, which will give us equals 64.2 minus 3 times standard deviation of 2.9. That'll give us 64.2 minus 3 times 2.9. Okay, that'll give us in decimals we got it as 64.2 minus 3 times standard deviation of 2.9. 55.5. So we got 55.5. 55.5 here, which is what we're gonna be here. 55.5. Okay. Now we'll repeat the same process for this to get the last one, so that we have mean plus 3 times standard deviation. So we got mean plus 3 times standard deviation. It gives me equals 64.2 plus 3 times 2.9. That gives us, just go to the decimals calculator and change this to plus sign. Now, you get the plus sign right here. Okay. Give me 72.9. 72.9. 72.9. So we got some 2.9 here. 2.9. So now we have everything that we have. So the mean is 64.2. On this side, we have 61.3. For this one, we have 58.4, and so on and so forth. So now we're ready to answer the question. It says, estimate the percent of women whose height are between 58.4 inches and 64.2. So you can see from here that this is 58.4 and this is 64.2. Can you see that? Hello, class?
Yeah, we can
see
see
that right here. Excuse me, my mistake. Undo. We are looking for the percent of women whose height are between 58.4 and 64.2 inches. The percent of them. So 58.4 is from here. You can see right here. 58.4 to 64.2. Can you see that? Hello, everyone. Hello.
Yes.
So you can see the percent we're looking for is from here to here. See? From here to here. So that from that we can now say the percent of women, okay, percent of women whose height are between 58.4, whose heights are between 8.4 inches to 64.2 inches, 0.2 inches. Is now equal. Now you can see the percent from here. From this place is 13.5%. 13.5% plus we have to see 4.2 have 34% from this side. So from here to here is 34%. 34%, which is equals they give you let me add this 10.5% plus 34%. So we can figure this out in Desmos. So you have 13.5% plus 34% is 47.2, 47.5% of women. 47. Let me take it again. 47.5%. Okay. It's 47. So 47.5% of women have the height of 58.4 inches to 64.2 inches. So this is basically what empirical rule is about. You answer question based on this. They can ask questions in different forms. Like as you can see, the first one we solved, they give us these values and say, find the usual rate, and then determine if a certain reading is unusual. The second way, they'll give you the number, they say, find the percentage, So there's another way, other ways they ask the question, but whichever way they use, you still have to be based on this thing that we have here. So that's basically what it is. Any questions on this? Any questions, guys? No. I always like to solicit questions in math class because students usually ask questions if they get confused. So anyway, since there's no question, that means I'm doing a good job. Well, Okay, in that case, any other question from, apart from this, what I just explained, any other question from any other team? The homework is going well?
Yeah.
Hello?
Actually, no, I had a question about the homework. I think one of my assignments, it says on, actually two of my assignments, it said it wasn't turned in for homework 2 and 3.
Who am I
And
speaking to?
test, Nick Taylor.
Yeah, Mr. Nick. I went to Pearson when I was trying to update it. I didn't see it.
That's weird. I
Because
think I'm gonna have to buy the I had the 2 weeks.
oh, you were doing it.
extended.
You were doing it when the 2 week expired. Is that what you said?
Yeah.
How come I just didn't see the.
But I completed those assignments. That's why I'm confused.
Nick Taylor, right?
Yep.
I went in there. I was able to got one for the one. Mr. Aaron, you're there, right?
Say it again.
Mr. Aaron, you there? Mr. Aaron?
Yeah, I'm here.
Yeah, because I was able to get his own. He had something similar issues that you had. The 2 weeks expired and he lost access. Then, but I was able, but the ones he did, I was able to get it. I don't know why.
Then let me buy that today, and I'll send you an email out and just let you know. Heads up.
Yeah, if you go in there and if they're still there, well, after you are in, let me know. I will go and update it.
All right. Thank you.
You're welcome, Mr. Aaron. You have a question for me, right?
Oh no, I was just asking because like the homework 4 was like giving me troubles. I know it's not due until the 14th, but it was just like kind of hard. So I was just like asking if I need help. Like, is there like, can I like email you or something like that, or
Maybe then I will solve something. I won't solve exactly that one you sent to me. I can email you a sample question. I will solve a sample question of that type.
Okay.
Or email you a video where that similar question was solved. Then I can so I can use that. Yeah.
All right.
Because the one that you have there is the one I want you to figure out. So I can give you what will help you, what you do in the class. None of them, is there any of them that wasn't covering what I covered today? Maybe those are the one that we have today. The one that where we are having problem with it. Maybe perhaps some of them are asked the kind of question we are solving today. Am I right?
All right.
So I'm asking, are they similar to the question we are solving today?
I think so.
Yeah, that's some of them. We have not done that yet, but we're gonna do it. That's what I'm doing today and tomorrow, and we finish everything. That's homework.
Okay.
So yeah, so after that, I mean, if you have a question like that, you can email me, and I try to respond to my email as quick as I can. So sometimes I might be slow because I have lots of it, but I'll try and email you some similar question and email to you. Then you can use that as a guide for that one. Okay. But I think after today and tomorrow, I mean, on Friday, you shouldn't have problem with that, because I'm guessing that those areas you're having issues are the area we are solving today and tomorrow and Friday. That's my guess. Now, those of you who are currently showing up, please continue, because you're not going to regret it. At the end of the semester, I'm going to say choose one assignment. Just choose any assignment that you're not doing well in, that you want to boost your grade on. Then you can choose it. I can boost your grade, at least maybe 10% bonus grade in that assignment, because of you are getting you are good attendance. Okay.
Okay.
So let me take your attendance again for today. Give me maybe a few minutes. Let me pull out your names. Okay. I got Aaron here. I got Ania. I got Chambers. I got Karina Nicholson. I got Nick Taylor. Okay. All right. High five for you today. So if you don't have any other questions, I'll see you on Friday. All right. Have a nice weekend. Sorry, have a nice day.
Sir, I emailed you about when I had got into contact with piercing.
Yeah.
They told me that I would have to get the access code like through Canvas and through you, but the one that you put on Canvas didn't work. So would you be able to like ask them for a different access code for me, or like
maybe I'll have to email them again. You got them on the phone?
Yeah, I had called and I did the online chat with them, and they told me that I had to go through Canvas through the access code that my teacher gave me.
That's one in Canvas. Maybe I have to email them.
Yeah, can you ask them, because the one in Canvas just didn't work for me.
Maybe I have to email them because the access code, that's the only one I have, really.
Yeah. And homework 1, I'm gonna hand that in today and put it in the homework 1 assignment on Canvas.
Okay, please, then I can let me know as soon as you put it there.
Okay. Thank you.
You're welcome. Okay, bye-bye.
Bye.